So we talked about big data and how I guess machines. A lot of in a lot of the scenarios, without a lot of human intervention, machines are left to sort of do the work of not only finding out correlations, but also trying to sort of use that correlation to sort of predict events out in the future, right? But is that really a good situation, right? So does it just correlate or does it cause it, right? And I think I'm in the and I'm sure a lot of us are, but I think the causality is very important, right? So let's take an example. Let's say you have a big data, right? And you say, you know what, you're trying to sort of monitor, say, suicides by hanging, strangulation, suffocation in this country, right? Okay. And you know what, that correlates, and this is actually real data. Okay, this is by this I think spurious. I think his website is Spurious Correlation, right, by Tyler Wiggin, and his website is Spurious Correlation, and he has all this interesting sort of plots and trends where he tries to make like fun of all the spurious correlations, right? So for example, here you are trying to sort of decide as to why suicides are happening, and somehow it ends up correlating very very well with U.S. spending on science, space, and technology. So technically, if it's a big data and if you have like thousands of some of these variables and some of these variables correlate, the models might be using, because if there is no human intervention, the models might actually end up using some of these variables to sort of predict, but that would not be a good thing, right? And there is this quote by Chris Anderson in the Wired magazine, right? Way back, about 12 years back, right? So petabytes allows us to say correlation is enough, right? But so the argument is that given enough statistical evidence, it's no longer necessary to understand why this happens, right? We only need to know what things happen together, right? Uh, so is correlation enough and is causality dead, right? The question is, can you make decisions on correlations alone, right? So will you be confident on making decisions like life and death on just correlation alone, right? Not me. Okay. So and to an extent it depends, right? I wouldn't say it's completely black and white. uh, it depends on the situation you are in, and I'll give you some flavors of that. Okay. Not this depend. Okay. uh, so the first thing is that uh, how much confidence do you have that the correlation will reliably occur in the future, right? And the simplest way to look at it is the frequency of that correlation that have historically occurred, and an understanding of what's causing that finding, right? Uh, and if the risk of acting and being wrong is not high, right? So if, for example, a very simple case is, uh, let's say you are you're serving an ad to someone who is doing a Google search. Let's say you're Google, right? And you're serving an ad, right? And you end up serving the wrong ad, right? Big deal, right? You're probably serving millions, probably billions of ads, right? A few of those ads basically don't make sense to the customer you're serving it to, big deal, right? But on the other hand, let's say I'm making I always come back to my world, right? And let's say I'm making a design decision on a tape out which is going to cost $1 million to my company, and one mistake is going to cause like $1 million loss, right? And I probably might not have a job, right? So would I rely on correlation alone? Right? No. The clarity of causality becomes very very important, right? The So in that case, I will not make a decision on correlation alone. Uh, and this is a plot I took from Dave Ritter from BCG, and he basically lays it out in this very clear and concise don't act versus act kind of domains, right? So, so for example, if the risks are on the y-axis, you have frequent correlations and clear causal hypothesis on the top side, and infrequent unstable correlation on the other side, right? And on the x-axis, it sort of goes from risks outweighs benefits and then benefits outweighs risk, right? So for example, if you have infrequent unstable correlation, which is on the lower left side of this y-axis, but then the benefits outweigh risks, right? Because let's say the benefits basically outweigh risk, then you're basically going to act, right? Because there's nothing to lose. There is no, or maybe there is not as much to lose, right? But on the other hand, if risks outweighs benefits, or the cost outweighs benefits, so on one hand it could be a situation where you bring it back to my world, where I'm trying to decide on $1 million investment in a design based on correlation, right? Infrequent unstable correlation. I'm not going to do that, right? On the other hand, if you're Google and serving ad, the benefits outweigh risks and costs, even though the correlations are infrequent, unstable. You're going to act, right? Let me bring it back to that New York City example I alluded to in the previous case, right? So consider the case of New York City sewer system sensors, right? So they detect the amount of grease that flows into the sewer system at various locations, right? So if the concentration of grease at a particular location, for example, let's say somebody is running an unlicensed restaurant, right? So officials will definitely send someone out to detect the source, right? So the confidence of that source, that cause of that sensor trip, is low, right? So it could be many other reasons why the sensor tripped, but the cost is trivial, right? So if they do actually end up finding out someone is actually basically throwing used oil into that sewer system, it's not a good thing for the environment, right? So in that case, the benefits, even though the correlation is low, with the fact that the sensors could be tripped for many reasons, right? So you are basically in the infrequent unstable correlation world, right? But the benefits outweigh costs, so you're going to send out someone to inspect, right? Let's take another example, right? So let's say PSA screening test for prostate cancer, right? It has a very weak correlation, right? It has very infrequent. You're again in the lower left quadrant, right? Very or lower left Y scale, right? So there is no clear causal explanation as to why the PSA should cause prostate cancer, right? And moreover, the preventative surgery prompted by the test did not increase long-term survival rates, right? And the risk associated with screening was high, right? With false positive leading to unnecessarily debilitating sort of treatments, right? And hence the American Medical Association basically reversed its previous recommendation that men over 50 should actually have a routine PSA test, right? So basically the correlations were, you were basically on the lower left-hand quadrant. There were infrequent unstable correlations, right? But the risks outweigh benefits, right? So basically you said don't act, right? So AMA decided not to act anymore with this PSA testing business, right? Let's take this thing where I came across where, you'll be surprised to find out that, and we're going to deal with risks as well in one of the modules, right? I hope I can cover that because that's an important element of our lives, right? We have life risks, we have accidental risks, we have disability risks, and we are going to cover a lot of this finance stuff in this coursework as well, because that's my own personal interest where I sort of dwell a lot into investments and risk management and all those things, right? So we're going to cover some of that thing, but you'll be surprised to find out that 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 insurance companies, right, when they issue you an auto insurance policy, right, the amount of money you pay is dependent on your credit score, right? Technically, if you what the insurance company is saying is that the fact that you are a good driver, okay, sorry, the fact that you have a good credit score basically means that you are going to be a good driver, right? Which which doesn't sort of add up as much, but maybe it does, right? So maybe you can sort of prove some kind of causality, but I bet you there is a lot of correlation business going on in the back, right? So now let's take another example, right? So U.S. Army, right? Say they designed a image processing software, right? And that's basically true, right? So they have an image processing software basically that detects flashes of light to locate the possible location of snipers, right? But imagine that, right? The same kind of flashes of lights could be coming out of a camera, right? So two causes, and hence the confidence is low. So it's an unstable correlation where the risks of killing someone who is innocent, okay, is very high. So multiple causes of that thing. So you're basically again in the lower left hand corner, and you're not going to act, right? So these are some of the stories as to where just going by correlation depends on the situation you are in, right? Yeah. So sometimes correlation is enough, okay, but at other times understanding the cause is vital, right? Um, and, uh, and I say you just don't want to fit your theory to data, right? And sometimes you have this tendency that you have this correlation, and you say, oh, okay, maybe there is this and this, just like the credit score example I gave you, right? I'm coming up with a theory that credit score, a better credit score means you are a better driver. So that's a theory. That's my theory, right? But is that really the case, right? Probably not, right? So you have to go out and see what's happening in the real world. What's the physical relationship that's causing the relationship, right? So the goal is not to figure out what is going on in the data, but what is going on in the real world again, right? And so don't let data replace your intuition, basically. Okay. And the goal is when the key is to know when it is enough and when it is not. So when is correlation enough, when it is not. And I come from a mix of mostly cause. I would say I come from mostly causal world, right? I cannot be making decisions in my business, in my line of business, on just on correlation alone, right? I need pretty strong evidence of causality before I am going to act on any data giving me some kind of an indication of acting in one way or the other, right? So that covers up a little bit of correlation, causation. We're going to get into the math part of it in the future, so hang on.